All right, so herding cats for fun and profit. And hopefully, eventually, what this means will become clear. Otherwise, talk to me at lunch. Okay, so who am I and what am I doing here? Well, I work for a small company called Profdoc Care, and we make a medical record system, like Edith said. A pretty big one. And we used to be really tiny, but the last couple of years, we've grown a lot. And so I'm going to talk about a little bit about the medical record system, although not that much, and how we work and what we had to change as we grew. And also some of the obstacles that I think growing as an sort of APL company you might encounter. And I'm going to talk a bit about tools as well at the end. All right, so what's this medical record system? Well, it's called Take Care or Profdoc HIS, depending on where we're selling it. But I'm going to call it Take Care, because that's what I'm used to. Okay, so what's special about this system? Well, it's huge. I don't know if you can see that picture, but it's really big. That's what's special about working on it. It's pretty complex. It has an emergency ledger for the emergency ward, the emergency department, where you can keep track of what patients are coming in and how they're prioritized, which ones are dying, so you have to treat them really quickly, and which ones are just being a bit fussy, so they can stay for a couple of hours. And then you have to manage all sorts of information about the patient we have, so we have to have sort of general overviews and summaries of information. You can send referrals to other doctors for consultations if you want to ask them something electronically. You can handle appointments when the patients are going to come in and plan that. You can monitor everything you sent out, orders and referrals, to make sure you get the replies you want. There are lab results. You can even manage the letters you send out to patients to remind them of their appointments. More lab results, measurements, height, weight, you can graph, development over time, time series, case notes, just the regular standard paper medical record you use. So, and this is like, I could have had easily 100 more of these screenshots. So this is a small sample of all the different kinds of information that are in the system. So it's lots of very different kinds of information, administrative and medical and all sorts of stuff. And it's, like I said, it's pretty big, 1.8 million medical records. And that's more than our inhabitants in Stockholm where it's used. So it's a lot. 30,000, at least mostly happy users. Sometimes they're angry with me, but most of the time they're good. 300,000 lines of APL, give or take, in around 12,000 functions. That's roughly equivalent to 800 million lines of Java. Of Java. Sorry, no, it's a bad joke. No one got it. Okay. 200 transactions per second during office hours. Less during at night, of course. But around 1 terabyte of data, which used to be kind of impressive, but really isn't nowadays. But I had to put it there anyway. And it's obviously all in Dyalog APL. That's why I'm here. All right, so it's a pretty big system, it's very sort of enterprisey medical informatics system. And what about us at Profdoc Care? Well, we're getting bigger. So this picture was taken a couple of years ago when I just started. And this picture is from the latest sort of medical informatics fair we went to, where you can see we have a very, very large and professional booth with a huge neon sign, and it looks very sort of serious. And a little bit scary, maybe. Okay, so that's us now, and this is us a couple of years ago. So it's going up. We're getting bigger, okay. And here are, I don't know if these numbers are too small to read, but here is something I made a little script that cooked up. It's the lines of code in Take Care. So here are, this is when I started in March 2005, and you see the dramatic improvement since I started. From 200,000 lines of code to 330 lines of code. 1,000 lines of code. And obviously, we'd want that line to go the other direction. It would be better if there were fewer lines of code, but you know, nobody's perfect. So still, the complexity is sort of still increasing, although we're working on decreasing it. Okay, so I said I was going to talk about a little bit of obstacles that you might face. And I think for us, even our experience is that even if you have a good product that has excellent qualities, when people find out it's an APL, you have to tackle sort of misconceptions or myths about APL among people who don't know it. And that's pretty common. But I also think there are a couple of obstacles that consist of things people that do know APL think about other people that don't know APL, which might also stop you from growing your APL business. Okay, so what's the first one? Well, the first one is that APL looks like a cartoon character swearing, and it's completely impossible to understand. And this is, of course, ridiculous, but a lot of people seriously think so. They go like, oh, it's just weird symbols. No one can read this. You can't write it in it. Which is, of course, nonsense, but still it's a common misconception that people have. Okay, so who's this guy? This is one of the top hits on Google image search when you search for APL programmer. So this guy's hard to find, right? so people think if it's written in APL, it must be like this, old and legacy and floppy disks and ancient mini computers. And you can't find this guy. Everyone says, how can it's written in APL? You can't hire APL programmers. It's impossible. So you can't find that guy, so you can't hire any people. He doesn't exist anymore. So that's one misconception. The other thing is integration is very important, right? So this is a chopper motorcycle that's integrated with a wood chip barbecue. And you can't do that in APL. Can't do it, no. So that's another misconception. APL doesn't integrate with anything, right? So we know that's false, but it's a common misconception. So you sort of have to convince other people that, yes, we have a web service, you can talk to it, you can talk to us, and we're open to the other systems in your IT department. We fit in. And that's also a common misconception among people that don't know APL. Okay, so what about the people that do know APL? I think a lot of you, or in the APL community, have a couple of misconceptions about the other guys that don't do APL, the non-APLers. And one of them, I think, is that they're sort of stupid. That regular programmers, they don't use APL because they don't know better. They would be more productive, but they aren't enlightened. And all the tools that they use and like, and they're sort of crap, but they just don't know it. And I think that's probably not true. There are some smart people using other programming. Maybe we could learn something from them. Okay, so anyone recognize this guy? No? Yes, John McCarthy, inventor of Lisp. And Lisp is a great programming language, right? And Lispers do things sort of like APLers. They define functions interactively in a sort of session, although they call it a REPL, read, eval, print loop. And they define functions interactively, and it's very dynamic, and you can sort of change things on the fly and connect to a running process and look at what's going wrong, and they have very advanced error trapping and stuff like that. And Lispers tend to live in Emacs, right? Symbolized here by this cute baby GNU. And they write all their code in Emacs, and they customize Emacs and this, and they love it. So, but we don't need to learn anything from that, no, because they don't use APL. Okay. So, and in this guy, you'll see facial hair is a common attribute among programming language inventors. This is Alan Kay, who co-created Smalltalk, right? And Smalltalkers, they live in the Smalltalk image, which is sort of like the workspace. And they redefine functions on the fly, and they're very object-oriented, and we're doing object orientation in the late 80s, early 90s, which is sort of pioneering. And they invented the concept of the virtual machine and having code to run bytecode compiled. And do also sorts of advanced just-in-time compilation to increase performance of dynamic code and stuff like that. But we don't need that because they don't use APL, so let's not listen to what they know. And then there are all sorts of other tools that other people, all the Unix guys use, well, maybe some of the really old-fashioned ones use VI, but most of the new ones use Vim, which is VI improved. And all the Java guys, they have this giant behemoth of an IDE called Eclipse, which I don't understand the word of, but it has all these sorts of features, and probably some of them are good, but, and then there's source control software, Subversion and Mercurial, but we don't need that because we got APL, so let's skip that. Okay. So, back to the first misconception, which is recruiting. You can't hire APLers, and this is what we hear, like the first thing usually we hear. The first thing they say is, okay, so you got the system, nice, what's it written in, Java? And we say no, APL. And they say, how does that work? You can't hire APL programmers. No, maybe the first thing you say is, how can you read it? It's just weird symbols. And we say, well, actually, surprisingly, you can. Okay, so how do you find this guy? Well, the answer is that you don't, because he doesn't exist. So the first step to hiring APL programmers is to don't hire APL programmers. And not that there's anything wrong with APL programmers, but there aren't very many of you. A significant fraction of all the APL programmers in the world are in this room right now. So if we had to look for APL programmers, there wouldn't be very many to choose from. So instead, you hire regular programmers, but you make sure you hire the really good ones. And they have no problem learning APL, it turns out, which is nice. And it turns out that learning sort of, maybe I'm biased because the system I deal with is sort of big and complex, but it turns out learning sort of the system and the architecture and how to move around it and the domain knowledge takes much longer anyway. So even if you have to start from scratch in a program language, it doesn't really matter. You can learn C to write an APL interpreter if you've done other systems programming. It's not that hard. Okay, so the other thing that's very helpful is when you, at least maybe now when the economy is tanking, it won't be the case, but we used to get a lot of applications. So one of the things that we thought helped a lot was filtering out the bad candidates early. Because if you just look at the resume or the letter they write you, it's surprisingly hard. So to do this, we have a form on our website that applicants have to fill in. And this form includes a bunch of questions. And one of these questions is a very simple programming test, which consists of just a little loop, and then you have to add a couple of numbers, and it says what's the variable said after this loop. So it's really completely trivial. And it's written in Python, and there's a link to where you can download Python, and they can just enter the code of the test, and they have the answer. But about 60% of all candidates get the wrong answer, so we know they're crap, which is helpful because then we can filter them out. And even candidates with really impressive resumes, like I have 10 years of experience in managing a team of 12 programmers in enterprise, blah, 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 and they can't add 2 and 2, so out with them. And that helps a lot. And we also have, the other thing is try to find indicators of greatness early, which also helps. So we have a couple of questions which we found indicate that you're good. And one of those is, we ask if they've done any programming or projects related to programming in their spare time. Not related to university or anything with the work. And virtually all the good ones say yes. So that's good. That's a good indicator. And we also have another couple of questions, like we care a lot about usability and user interface design. So we have a couple of questions relating to that. But you might not, so you might need to put different questions. And then we have a couple of regular questions. They attach their resume and sort of why do you want to work here, and regular stuff that you all probably do anyway. Okay, so then on to the interview. And now you filtered out some of the candidates. So the important thing is have candidates write code during the interview. I have no idea why people don't do this every time, but our interview has 3 parts. One programming test, where they solve 3 sort of smallish problems in a subset of APL that we teach them during the interview, very, very small subset. And then we have a design part of it where they critique and redesign a user interface, because that's important to us. And then we have sort of a regular part where they talk about why they want to work there with our CEO. And this is very good because you can easily compare candidates because everyone does the same thing. So rather than just sit talking, you sort of have a format, which is nice. Ta-da, it works. For us at least. So surprisingly, people have no problem learning APL, or maybe not surprisingly, I don't know. And they tend to write pretty verbose code at first, because it takes a while to sort of get into it. But you can check that if you just review the code they write and sort of give pointers and teach them a better way to do it, a better idiom. It works fine. I mean, hiring is really not a problem for us. Not at all. So that's a myth. Busted. Okay, so growing pains. Sadly, growing is not all rainbows and lollipops, but problems actually turn up occasionally. So what are some of the problems we hit? As you get bigger, I think, especially since we were like almost only 2 programmers, and then we scaled to like 5, that's a big, big step, going from 2 to 5. And then now we're 15 or so, depending on how you count. So you have to change stuff. So what do we have to change? Okay, the third thing we had to improve was documentation. And I think, I'm not saying you need to become some enterprisey place where everyone has to document everything in minute detail, code stuff that's apparent from the source code anyway. But we did have to improve sort of the big picture stuff. Why is the architecture this way? What are the advantages of that? So you sort of can tell the design parts from the accidental parts that just happened due to historical accidents. And we did this by installing a wiki, which I think worked great. A wiki is nice because there's no need to produce sort of an official looking document. You can just jot something down, and then the next person finds it and he improves it, and gradually, sort of after 2 years now, it's really pretty good. And the problem now is sort of organizing the information. It's full of useful stuff, but maybe not easiest to find always. So that's good. And the other thing we had to do was we had to slow down a bit. We used to make one release a week, sometimes more, which I've come to understand is kind of a lot. So it turned out as we got bigger and as the system got bigger, we just spent too much time managing releases. So it didn't work. So now we make one every 3 to 4 weeks, and that's much better. But I do think that time-based releases that always happen on a certain schedule is much better than sort of having a big version release, because it makes things more stable, and you sort of avoid the system of having the unstable next version going on for infinity, never stabilizing, because everything that's stable goes in the time-based release. Okay, so the other thing we had to do was we had to start reviewing code more. Everyone used to be an expert, right? When you're 2 people, everyone's an expert. But when you're 12 and the system is 300,000 lines of code, there are parts of the system that people don't know. And now suddenly, since we hired quickly, most people were beginners, so we had to review code much more. And we had to test much more. And to do this, we had to improve our tools, which is my next point, so I'm going to get this. But basically, whereas a couple of years ago I spent virtually all of my time writing my own code, now I spend a fair amount of my time looking at other people's code. So that's a change, for me personally at least. Okay, so doing more code review and testing, among other things, we need to get better tools. And I think this is, I don't know if this is typical, but I get the impression it's typical of APL shops that you tend to have all your own tools, right? So you have, when I started, we had our own source control system, and we had our own diff and merge tool. No, sorry, just diff, it didn't do merge even. And we had our own bug tracking system, and everything was sort of custom made. And I don't know what you guys do, but just as a background, we never stored code, we never saved code directly to workspaces. But we edit in the session and do things interactively and stuff like that. But then we saved 2 component files that were used and we used those component files to rebuild the workspaces as we went to release. So we sort of had a build system in place already. Okay, but they're all these standard tools, but you can't connect them with APL because it lives in some sort of custom binary formatting component files or something or other, which I think is very common. So, but now we have Unicode. Yay, Unicode. So it even has a heart symbol. It's nice. Okay, so if you put your code into text files, and you don't have to store it there permanently, you can just write it out to use a certain tool during a certain time. Then you can integrate with all these wonderful tools. And it's, I mean, doing the code to write stuff out to text files is like a day of work. And you get UTF encoded, and everything just works mostly. Okay, so this is our old diff tool. We had one which was printed in the session, the 2 lines that were different. And this is sort of this is not a real change. I just picked something that was reasonably short. Okay, and then we had this one, which I think is written by someone called Rex Swain. I don't know. And it was graphical, but it would sort of become confused if you made a lot of changes, and the diff would be sort of nonsensical, and the GUI wasn't very good, then it would sometimes slip outside the screen and stuff like that. So it's sort of annoying. And it didn't have any support for merging. So if you were comparing 2 things and you realized you wanted one change from one part and one change from the other, you couldn't merge anything. So since I was spending lots of time reviewing code, I figured, why don't I just write the stuff we're comparing to text files, and I'll use an off-the-shelf diff tool. All right. So there's one called WinMerge. There are like a zillion decent ones out there. WinMerge was pretty good. It handles Unicode. And this is what most people at the office still use. And it sort of works, but there are a couple of problems. First of all, there's no syntax highlighting. And in this example, that doesn't really matter because the code is so short and simple. But sometimes when you have more complex code and long lines, you might find that you think you're looking at code, but then you realize there's a comment character way off to the left. So you sort of miss that you're looking at a comment and it's not important. Or you miss a syntax error so that it has been caused by something because it's not highlighted. And you can also see here that it doesn't tokenize, it doesn't know how to tokenize APL. So it thinks that first a token looked like this and then it looked like this, which is of course wrong because I've changed that token to that and added an extra token there. So in this case, this isn't too bad, but sometimes you get a fine difference where it marks the entire line and you have to manually sort of look for what actually changed, which is also annoying. Okay, so I looked at a bunch of diff tools downloaded off the internet, and I looked if they could do custom syntax highlighting at first. So I figured you have to be able to write some regular expression and make it at least have a decent syntax highlighting. But none of them did. Not even the big commercial ones that cost like $200. But then I realized, aha, I use the world's most extensible text editor building platform, Emacs. Emacs definitely has support for custom syntax highlighting, and it has support for diffing. So I spent a Sunday on that, and voila. Okay, so here's APL with basic rudimentary syntax highlighting. It's not perfect, but it's pretty good work for a Sunday. And it has decent tokenization of APL. So even though the comma is here, so it's slightly wrong, it's at least much better than the WinMerge one. So the point of this is that just by sort of being open to the other tools that are out there and spending a little time and writing code to text files, and you don't even have to store your code in text files long term. You can just write them out when you're doing the diff from a APL function in your workspace. You sort of gain a lot because instead of implementing an entire diff program, which would have sucked compared to Emacs, you get all of this for free. And my life is now much easier because I don't have to use a crappy diff tool, but a good one. Okay, so source control. When there are more developers and you don't know as much what everyone's doing, and sometimes you inherit some code that someone else wrote like 5 years ago, and you see some line that looks strange, and you wonder, why is that line like that? And is that line different from the other lines? And who changed it and stuff like that. So there are plenty of source control systems. We currently use Subversion, which is fine. You can use that. There are other ones that are slightly more modern that I think fits more with how most APL developers work, that are distributed, so they aren't as centralized, but you can work on your own computer and sort of integrate changes between each other, like Mercurial and Darks and Git. But Subversion is very good if you're a sort of Windows guy because it has a Windows GUI and you don't have to enter stuff at a command line. And I thought I'd just show, I have like a toy Subversion repository here. So this is just Windows Explorer, and I can right-click on a file and I can see all the changes that have been made. And I can even double-click here. And I get a diff in Emacs. So suddenly I have all these tools at my disposal. And you can see I added a right paren there. Okay, so
did you implement merge in your Emacs?
Yeah, it's already implemented. I didn't do anything. It just automatically works. And so this is really nice. And of course, because I'm using a standard source control system as opposed to a custom one, if I now, for example, open a file, I have a file here in this repository open in Emacs. Maybe I should increase the font size. Oops. I have it set to always show like 80 columns, so the font size big it gets. Okay, so I have a file in Emacs here. And now, because it's using a standard source control system, there are all sorts of features that are already done for me. Okay, so this is a mode called annotate, where it colors every line according to what version it is. So if I'm wondering about a specific line, I say, see, that line changed. It's different. It's newer or older or from a different revision than all these other lines. And I can, if I'm looking here, I say, okay, who made that? What change prompted this? Why did someone do this? And I can go directly to the log of the change and see which developer did it, which in this case is a developer called Profdoc, and when it was made, and who's. So you gain all sorts of neat tools that you just need to learn instead of having to build them, which is nice, I think. So it all integrates, almost at least, except when it times out and you have to call the hardware company to make it fucking bang things. Okay. And the other big thing we changed was automation. There used to be a lot of manual steps to doing things, like building the system from source and then distributing it to the customer and stuff like that. And we wrote APL programs to do most of that stuff. And there are, of course, standard tools, build tools, to do things like build things and have rules and say that if this changes, then use this program to build this file and move it here and FTP it to this server and stuff like that. But most of the metadata that we use to build the system is in APL. So it wouldn't have been practical to use a standard tool, because then we would have to translate all the metadata to sort of a text file format or something. But that depends on sort of where you're starting from, I think. And this also does stuff like translation of strings that are marked to be internationalized and stuff like that. And it really helps a lot, and especially for new developers, because usually there are like a ton of steps that the old hands, the experienced ones, know. So first you have to do this, and then you have to remember to check the output here, and you have to twiddle this. And so if you all just automate it, so there's a big shiny button you can just press, that makes it much easier. And that means beginners can start, and then they can learn the hard stuff after a while, when they're finished. Okay. So this is the conclusion. I might have to be more explicit in step 3, but it's a start. It's a start, and hopefully, if you do this, so the conclusion is that hiring APL programmers, which was a myth, is not a problem, as we've shown, I think. And if you just open up a bit and free your code from being isolated in a component file somewhere and open it up to the world, you can find all sorts of great tools that can really help you in your everyday work if you keep an open mind. And hopefully this can lead to you growing your APL business. All right, and before I do questions, I just want to show something. Really cool. So hopefully if you do this, this is what you end up with. Oh, there's no picture. Oh, never mind. It didn't work. All right. So that's it. If you think I'm completely wrong and off base and I'm destroying the APL legacy, you can come challenge me at lunch. Yes?
One problem, we're working with a large number of lines of APL code. One thing is to define differences and so on, but coding standards, standard utilities and so on, cannot be without that. that okay from the beginning?
There probably wasn't. There were sort of, no, there wasn't really standardized what things were called. Oh yeah, sure. The question was about coding standards. How do you manage to make things sort of, the names of function be consistent and stuff like that? And of course that's a problem. And things weren't really consistent to start with. So we tried to sort of codify what the most common alternative was of all, and we tried to make new code follow that and make things work the same way. But we had a large code base to start with that wasn't really consistent. So I don't think it's not worth it to sort of redo everything, because that leads to problems. But you can sort of make sure that anything you change or write new stuff, it goes in the right direction.
Yeah, I also mean that you have, when you bring in new programmers, you have to drive them into a certain area of programming. So you write code so it's readable for others.
Yeah, certainly.
And also actually searchable.
Yeah, of course. I mean, people, obviously, if you're a complete beginner, you don't write great code from the start. You need training. But my point was that maybe the training is not the hard part, but learning the system and understanding how it works. And at least for us, that's what takes more time. Yeah?
And I use VI for editing. Do you think I would like Emacs better if I took the time to learn?
Well, as I'm an Emacs user, obviously, I mean...
But you know both?
No, I don't. No, I have friends who are hardcore, not VI, but Vim users. There's a VI emulation mode for Emacs. So the keys are the same. You could try that. It's pretty different. But the nice thing about Emacs is that it's infinitely customizable. And the stuff I did there was like maybe 100, 150 lines of Emacs Lisp. So, and I didn't know any Emacs Lisp when I started. So it's pretty easy to sort of mold it so that it works the way you want it to, which is nice. Yes?
Do you use Emacs for Windows?
Yeah, sure.
Okay. I use something called Epsilon, which is designed based on Emacs.
Okay.
But maybe missing some of the functions or a different one. Do you happen to know it?
No, I don't know. I use GNU Emacs, which is like the biggest version. I haven't tested the stuff I've done with the Xemacs or any of the other Emacs derivatives. But if people are interested, I can put the code up somewhere on the web, and you can try it. And if it works for you, or you can send me a patch that makes it work for you, that's fine.
You're saying that you can pass out your code for market for syntax?
Yeah, sure, of course, yeah. If anyone's interested. Yeah. Yeah, we mostly we do sort of manual testing. We do some automated testing, but not that much if you count by volume or how much time it takes. So all the new stuff we do that's easily testable, like utility functions and small sort of more pure programming stuff, that has automated tests. And then we have sort of a maturing area or baking oven where people put stuff that they're not sure is complete, but the programmer or developer thinks it's complete, and then people bang on it and for a while, and it sort of matures, and then when we can't find any errors, we move it to the next release version, and then a week or so before release, we freeze everything there, and then people do integration testing and test all the stuff that's been put there sort of together to make sure it works together. So we sort of first have a maturing phase, and then when it's mature enough, we bring everything together and do integration testing. But the thing is, because the system is so large, and there's so many transactions, even like tiny, tiny bugs that happen once every 100,000 cases turn up within minutes in the logs. So usually, even if there's a small bug, we notice it very quickly in production and can fix it sort of live, because we do a lot of logging, so we can find, just because sometimes you can't even find the bug by testing because it's so obscure and it only happens on like certain versions of Windows 2000 where the Alt-G key, a certain printer is installed or something. So it's, yeah.
How do you push out the code to your client?
It works. We upload it to an area on the server where we have access, the workspaces, and then they just move those in, And if it's just the client that's updated, then the clients download the new code, the new workspace automatically from the server. So we have a built-in sort of version management. Every time you start, the client asks the server, these are my versions, what are yours? And if they diff, it downloads the ones that differ. And if the server changes, then we upload the code, and an administrator moves the code into the server, the workspace, and then we tell the server you have new code, please update yourself. And it updates itself by copying the workspace. And then after that is complete and works, then we push out the client part, and the client start downloading the new updates that then take advantage of the new features on the server.
The clients are doing it unknowingly or knowingly?
No, the clients always know when you log out or when you start the client, they ask the server and say, do I need anything? And the server says, yes, here. And then they download it.
The software saying that or the user saying that? The user sees there's nothing.
No, the user doesn't do anything. He just logs out or in, and then there's a little progress bar saying updating. Goes to the end. That's it. Yeah.
Looks like you have a fairly large user base and they're fairly heterogeneous. How do you manage the client support?
We don't do any support. We do sort of third-line support. So the users call help desk on the hospital because we can't even do first-line support because a lot of it is about the regulations of the hospital and what you do if you have a medication order and the computer is broken and you have to have a paper copy, and it's not even related to our system. Or maybe they call them and say, well, take care, it isn't working, and it turns out their keyboard is broken. I said, there's nothing we can do. So, but then if there are more advanced questions that the help desk thing forwards upwards along the chain, and they think are not a problem, is a bug, or is something that indicates that we need a new feature, they contact us. So we're sort of a couple of lines back from the users. But sometimes we go out and talk to the users directly, but not for support. Yeah.
How many hospitals are actually using this facility?
Oh, most of Stockholm, really. So it's Karolinska University Hospital, which is 2 sites, one at Huddinge and one at Solna. And like that is huge. 7 operations per hour, 24/7, every day of the year or something. And then Södertälje sjukhus. There's a small geriatric care unit called Hårsman, a bunch of primary care centers. And we're going to expand now, so basically all of Stockholm. Say, but not anywhere else in Sweden. Yet, exactly. Yeah. No, you don't, actually. You have to be certified. You have to pass a certification to provide some, I don't know, it's called medical equipment. So if you have like a machine that's connected to the patient that measures heart rate or something like that, then you need to be certified, but not for medical record systems. No. Yeah.
I hope I agree on the fact that you can talk to the pioneer software and writing APL. What kind of time frame do you see for government to be productive? 1 month, 2 months, 6 months?
It depends on what you mean by productive. Usually the first thing they do is we give them a toy application to write, which is like a phone book. So you can add a contact and enter a phone number and a name, and it has persistence when it saves the file and stuff like that. And that usually takes about 2 weeks maybe to complete, I'd say. And then they start with sort of a real project. And usually the first code that's sort of in production, real code, it depends on sort of when releases are planned compared to what project they're doing and how big, but I don't know, maybe a couple of months, 6 months, and then they have code in production. Yeah.
Type of people. Are they new people from the university or usually experienced programmers?
No, we're very mixed. There are a couple of people that are fresh out of university. I was fresh out of university when I started. Some people have worked for a while, but I think it's very common, and of course I say this because I'm young, but I think it's very common in the IT industry to sort of focus on years of experience. And experience is good, but if you start out bad, years of experience doesn't necessarily help. They move you, it's like the likelihood arrow. They move you forward, but if you start off way up there, then... So we have plenty of people applying that sort of have many years of experience, but still can't solve the elementary programming question. So I think you should sort of focus on ability, and experience is, I think, extremely valuable when it comes to sort of leading a project and knowing how to handle the users and requirements and stuff like that. But for learning APL, I don't think it's so relevant. All right. Thank you very much.